Millions of years ago, survival relied on a very simple action: smashing one rock into another. Fast forward to the end of the Stone Age, and our ancestors are slicing leather with millimeter-thin stone blades. To us, these might look like a random collection of rocks, but they represent a 3 million-year evolution in engineering. Early hominins living across the Indian subcontinent needed sharp edges to cut meat and process wood, but their manufacturing process was flawed by waste. This illustrates the tool-to-stone ratio of direct percussion. You hit a heavy river pebble with another rock, and the result is a thick, unpredictable flake. You end up with a massive amount of wasted mass and a tiny sliver of cutting edge. As early populations expanded into increasingly demanding environments, from the Siwalik foothills to the deep forested valleys of the Deccan, brute force was no longer enough to keep them fed. They had to extract exponentially more cutting power from the single piece of stone. That challenge triggered a 3 million-year technological arms race. The first major upgrade arrives during the Lower Paleolithic. Instead of just bashing rocks together, early humans developed soft hammer percussion. By striking a stone core with something softer and more elastic, like a piece of bone or antler, they could detach much thinner, broader flakes with greater precision. This level of control allowed them to shape tools on both sides. The result was a symmetrical toolkit, dominated by teardrop hand axes and cleavers from ancient Indian sites. To craft this, hominins held the final symmetrical shape in their mind before striking. Archaeologists call this a mental template. Early humans moved to executing a deliberate, planned design, imposing their own geometry on the stone to maximize utility. Even with a mental template, carving a large core down into a single hand axe leaves a large pile of unusable rock shards on the ground. The Middle Paleolithic solves this by flipping the script. Using what's known as the levallois technique, engineers stopped trying to shape the core itself. Instead, they carefully pre-shaped the core's surface, so a single strike pops off a perfect, ready-to-use flake. This systematic preparation allowed humans to dictate the flake's exact geometry. By turning flakes into primary tools, they harvested maximum usable edge. To pull off this kind of precision, they had to upgrade their raw materials. They abandoned chunky, unpredictable quartzite and hunted down fine-grained, brittle rocks like chert and agate. They were mastering the specific physics of different minerals. By matching the right material to the technique, they gained absolute control over their manufacturing output. Then the climate shifts. As the dense Pleistocene environments gave way to lighter forests, early humans had to hunt smaller, faster prey. A heavy hand axe is useless against a darting antelope. They needed lightweight projectiles. The solution was mass production. Using an intermediary punch tool, they consistently sheared off long, uniform blades with perfectly straight, parallel edges. Over time, these were miniaturized into microliths, tiny geometric stone fragments just 1 to 5 centimeters long. A piece of stone that small is impossible to hold in your hand. Microliths were designed to be slotted into wood or bone shafts, acting as interchangeable razor-sharp teeth for arrows and sickles. By engineering multi-part composite tools, humans achieved a standard of modular repair. If an edge chipped against a rock, the hunter simply swapped the tiny stone fragment for a new one without discarding the handle. As we enter the Neolithic period, human populations face a completely different environmental challenge: settling down to farm. Slender microliths are great for hunting, but they shatter if you try to chop down a tree. Clearing forests and building permanent structures required a return to heavy, high-mass tools. Instead of chipping the rock to an edge, Neolithic engineers spent hours grinding and polishing igneous stones against coarse slabs with sand and water. The friction created a smooth, resilient axe, or celt, that could absorb the massive impact of felling timber. At the same time, for daily chores like cutting and scraping, they continued to mass-produce razor-sharp, standardized chalcedony blades. This dual-purpose toolkit provided the specific mechanical advantages required to clear the land, plant crops, and build the first permanent agricultural settlements across India. Look at the sheer math of what happened over 3 million years. Early humans moved from deriving a few inches of crude edge from a 2-pound rock to feet of razor-sharp edge from the same volume of stone. That optimization required shifting from reactive impacts to abstract, multi-stage planning. These artifacts serve as the physical, fossilized record of human cognitive evolution, mapping the exact moments when our ancestors learned to engineer the physical world to match their mental intent.